lesson is going to be about solving absolute value inequalities. So we are talking about inequalities this time, not equations. That means we're going to have less than or equal to, greater than, and greater than or equal to. So we're going to have those inequality symbols. Now, at the beginning of an inequality expression, you're going to do the same thing as with an equation. You're going to isolate the absolute value expression by using the reverse order of operations. Once you isolate your absolute value, you need to make sure the absolute value expression is on the left of the inequality symbol, because making sure it's on the left is going to make sure that the shading part, once we're actually shading, is correct. So once you have that absolute value on the left of your inequality symbol, you need to determine what type of statement you have. You can have either an and statement or an or statement. If you have less than, that's this symbol right here, or if you have less than or equal to, that's this symbol right here, then you're going to have an and statement. And in an and statement, you shade between the two numbers that you find as part of your inequality, as part of your absolute value inequality. So you're going to find a lower number and a higher number, and you're going to shade in between when you have less than, when you have an and statement. If you have less than or equal to, the only difference is not only are you going to shade in the middle, but you're also going to shade your beginning and last point. With less than, you don't shade the beginning and end point. You keep them open. They're both going to be open, but with less than or equal to, the equal to part makes it closed, so it's going to be closed there. Now, we also write this in something called interval notation. Interval notation basically just states the first value and states the last value. And the way we write that with less than is parentheses, the first value, comma, the second value, close parentheses. With less than or equal to, we're going to have brackets instead of parentheses. The brackets means we're including the numbers. The parentheses means we're not including the numbers. So we would have bracket, the first number, comma, the second number, and then a bracket. So that's the and statement. Now for the or statement, you're going to have greater than, which is this symbol right here, or you're going to have greater than or equal to, which is this symbol right here. And in an or statement, you shade on the outside of the number line. So you're going to have shaded from negative infinity until your first value, and then you're going to skip a section in the middle, and you're going to go to your second value and shade after that until infinity. Now, if you have greater than, your two major values are going to be open. So they're going to be open. But if you have greater than or equal to, they're going to be closed. So same thing with our interval notation. Since we're shading at negative infinity, we're going to start with parentheses negative infinity. Then we're going to go to our first value, A, and we're going to use a parentheses to close it because it's open. Then we're going to have a break right here. This break right here represents this U. That union is that break between A and B. So then we start at B, so we're going to open a parentheses and go to B, and then we go to infinity, so then we put comma, infinity, and close with a parentheses. Now with greater than or equal to, it's exactly the same. The only difference is that in the middle at A and B, we have brackets because these are closed. These are open, so we have parentheses. These are closed, so we have brackets. So remember, less than or equal to is and, greater than or equal to is going to be or. And statement, you shade in the middle. Or statement, you shade on the outside. If you have less than, it's going to be open. If you have greater than, it's going to be open. If you have less than or equal to, it's going to be closed. If you have greater than or equal to, it's going to be closed. Okay? So hopefully this kind of gives you a good introduction as to how you're going to shade your number lines. But we don't really know what this means until we see an example. So let's go to example 1. Okay, so here I have the absolute value of y is less than 6. Less than is an and statement. So I'm going to write two inequalities. I'm going to write y is less than 6. I'm going to copy it down just as it is. And then I'm going to say and y, and I'm going to flip the inequality. I'm going to say greater than, and I'm going to change the sign, -6. So there is my and statement. The absolute value of y is less than 6 means that y is less than 6 and y is greater than -6. So now we can put this on our number line. So we're going to put a number line, and we're starting at -infinity over here, +infinity over here, 0 is somewhere in the middle, and the first number I'm going to plot is the -6. -6 comes first, and then +6 comes second. Now, I don't have an or equal to part, so my points are open. And this is an and statement, so I shade in between. And now for interval notation, my shaded part starts at -6, goes all the way to +6, and they're both open, so they're both going to have parentheses. So now in this other example, we're going to do the same thing. This is going to be y is greater than 6. This is greater than, so this is going to be an or statement. And then we're going to say y is less than. Notice I flipped the inequality. It's flipped. And we're going to change the sign to -6. Once again, we're going to draw a number line starting at -infinity, going to +infinity, 0 somewhere in the middle, -6 is first, +6 is second. Notice this does not say or equal to. It just says greater than and less than. So they're both open. So we're going to put open circles on both of these. And this is an or statement. So we're going to shade on the outside. We're going to shade on the outside. So now in interval notation, my shading starts at -infinity. So parentheses, -infinity. Comma, and it shades until I get to -6. And it's open, so we use a parentheses. Then I have a break. See how it's blank here in the middle? So that's going to be my union. And then I open a parentheses because I have an open circle at 6. We're going to start at 6, comma, and then it shades all the way to infinity. So we're going to go to infinity here. And then we're going to close the parentheses. So this is two very simple examples on how to do inequalities. So let's go to the next example. Okay, so here we have our next two examples. We're going to start with this one right here. And my absolute value is not isolated, so I need to subtract 8 from both sides, eliminating the 8. And we get the absolute value of x minus 3 is less than -4. Now there's a problem here. This is a positive number. Absolute value is always positive. But this is saying it's less than -4. A positive number can't be less than a negative number. This doesn't make sense. So this is a false statement. This is false. So what that means for my number line, starting at -infinity to infinity with 0 in the middle, that means I don't have any numbers on my number line that work. So my number line is going to be empty. So my solution is the empty set. So in other words, there is no solution. Well, let's take a look at what happens when we have a similar situation, but instead of less than, we have greater than. So we're going to subtract 8 from both sides here, eliminating the 8. We have the absolute value of x minus 3 is greater than -4. So this is saying a positive number is greater than -4. Well, positive numbers are, of course, greater than -4. In fact, this is always true. So what that means for our number line, going from -infinity to infinity with 0 in the middle, if it's always true, then it's true everywhere. So we're going to shade the entire number line. So now for interval notation, my solution starts at negative infinity and it goes to positive infinity. And this is another way of saying all real numbers. So if my absolute value is less than a negative number, I have no solution. But if my absolute value is greater than a negative number, then I have all real numbers. And this is true even if you have the or equal to part. So if I changed it to or equal to over here, this would still be true. This would still be the same. I would still get no solution and I would still get all real numbers. Okay? Let's go to the next example. Okay, so in this example, I have 2 times the absolute value of 3x minus 3 plus 6 is greater than or equal to 18. My absolute value is not isolated, so I need to isolate it. So we're going to subtract 6 from both sides here, eliminating the 6, and I get 2 absolute value of 3x minus 3 is greater than or equal to 12. So now I divide both sides by 2, eliminating this 2, and I get the absolute value of 3x minus 3 is greater than or equal to 6. This is greater than or equal to. So this is an or statement. So now I need to make 2 inequalities. I need to say 3x minus 3 is greater than or equal to 6, or 3x minus 3 is less than or equal to negative 6. So now we need to solve both of these. So we're going to add 3 to both sides here, eliminating the 3. 3x is greater than or equal to 9. Divide by 3, reduce, and x is greater than or equal to 3. So that's the first inequality there. On the second one, we're going to add 3 to both sides again, eliminating the 3. 3x is less than or equal to negative 6 plus 3 is negative 3. Divide by 3, reduce, and x is less than or equal to negative 1. And this is an or statement. So now on our number line, we're going to start at negative infinity, go to positive infinity with 0 in the middle. Negative 1 is going to be over here somewhere. And then positive 3 is going to be over here somewhere. This is greater than or equal to. The equal to part lets me know that this is closed. This also has a or equal to. This is less than or equal to. So this is going to be closed. Now, this is an or statement, so we're going to shade on the outside. So let's shade the outside here. So now interval notation, my shade starts at negative infinity. So negative infinity, comma, negative 1. This is closed, so I'm going to use a bracket. Union, because I have a break. This is closed, so I'm going to have a bracket, 3, comma, infinity. Remember, if it's open, you use a parentheses. If it's closed, you use a bracket. This is closed, so we're using a bracket. Okay, well, I hope you enjoyed today's lesson on solving absolute value inequalities. That was a lot of information. So if you have any trouble, please make sure you send me a message in Schoology, or you can send me a text. Have a great day, everyone.